The next question is from the Boolean algebra, and we can see here that which of the following Boolean expression is a tautology. So, let us see these four statements first. The first statement, let us check it, what it is saying here. We know from various operations what can be done here without making the truth table, just simply following the basic rules. We can have P, or we can write here Q or P, again or negation of Q. Now again we can make a simple change here because the or is commutative. So, I can replace Q or P with P or Q again. Now here we can make this simple change, and you know Q or negation of Q. Now from here you know it that Q or negation of Q is always true, and again P or P will give you P. Definitely this is a tautology. So, the first option itself is correct, and there is no need to check all other options. Let us move on to the next problem. The next question is again from limits. It says that limit x tending to 1 x raised to the power 4 minus 1 upon x minus 1 is same as limit x tending to k x cube minus k cube upon x square minus k square. Then what is the value of k? Now this is actually related to a very standard result, that is limit x tending to a x raised to the power n minus a raised to the power n upon x minus a is equal to n a raised to the power n minus 1. So, this is the standard result we have, although we have different methods to evaluate this limit as well. We can factorize the term, or we can apply L'Hospital rule. So, we are using this here, a very easier one. So, you can check it from here, limit x tending to 1 x raised to the power 4 minus 1 upon x minus 1. Now here you can see the value of n is 4 and a itself is equal to 1. So, this limit will be equal to 4, 1 raised to the power 3, that is equal to 4. Now again the second limit which is given to us, let us evaluate this one. What is this? So, we have from here limit x is tending to 1 x cube minus k cube. Now I am making one change, this is x minus k, I am dividing with x minus k, and definitely I am going to multiply with x minus k for this part. Now you can see, you can apply this result here. So, what will be this like? You can see here that x is tending to k here. Now this is again of the same form, here n is equal to 3. So, this is 3 k raised to the power 3 minus 1, that is 2, and here what we can here have is in the denominator itself, here n is 2. So, it is 2 k raised to the power 2 minus 1, that is 1. So, this is the limit. Now equating with 4, we have 3 by 2 into k is equal to 4. So, k is definitely equal to 8 by 3. So, the option which is correct is the third one. So, let us move to the next problem. Now here again is a question from conic sections. What is given here is, if the directrix of a hyperbola centered at origin and passing through the point 4 comma minus 2 root 3 is 5x equal to 4 root 5 and its eccentricity is E, then which of the relation is correct in terms of E? So, what is given here is, let us see, we are given that a hyperbola is there which is passing through 4 comma minus 2 root 3 and it has this directrix. The directrix equation is 5x minus 4 root 5 equal to 0. Now, the center of the hyperbola is at origin. Now, we know the distance of the origin from the directrix is definitely a by e. So, you can notice this line which is equal to x 4 by root 5 and this directrix is x is equal to a by e. So, if we equate these two, we have a by e is equal to 4 by root 5. Now, this is the first relation we are having here. Now, what else is given here? The hyperbola is passing through 4 comma minus 2 root 3. So, if we assume the equation of the hyperbola as x square upon a square minus y square upon b square equal to 1, and if I satisfy this particular point here, we have 16 by a square minus 2 root 3. The square of 2 root 3 is definitely 12 by b square. Now, what I am going to do? I am replacing b square with a square e square minus 1. This is equal to 1. Now, we need a relation in terms of e. So, definitely we have to eliminate a from here. So, a is equal to 4 by root 5 into e. Now, let us see what we are having next. Now, from here you can see 16 into e square minus 1 minus 12 is equal to a square e square minus 1. Now, finally, if you replace this a with 4 by root 5 into e, you will get an easy relation in terms of e, which is definitely equal to the option number 2nd. So, finally, you will reach this relation in few easier steps. Let us see the next problem.